When you board a high-speed train gliding through the countryside at over 300 kilometers per hour, you're experiencing one of humanity's greatest transportation achievements. These sleek, bullet-shaped machines have, honestly, revolutionized how millions of people move across continents, connecting distant cities in just a few hours, transforming economies, and, well, reshaping the very fabric of modern life. Across Europe, Japan, and parts of Asia, high-speed rail networks have become the backbone of efficient, sustainable travel. But in recent decades, one nation has emerged from virtually nowhere to dominate this technological frontier in a way that has stunned engineers, economists, and governments worldwide. That nation is China. Just a quarter century ago, China's railway system was antiquated, creaking along with outdated infrastructure that couldn't serve its massive population. Today, it operates the world's largest and most advanced high-speed rail network, spanning distances that, honestly, dwarf every other country combined. But the story gets even more remarkable when you look behind the factory doors. What if I told you that inside certain Chinese manufacturing facilities, a complete modern high-speed train, with all its complexity, precision engineering, and cutting-edge technology, can be assembled from start to finish in just 12 hours, and that this entire process requires only 30 workers? This isn't science fiction. This is happening right now, and it represents a manufacturing revolution that's rewriting the rules of industrial production. Today, we're going deep inside China's train-making empire to understand how this became possible, what it means for global transportation, and why the rest of the world is scrambling to catch up. To truly appreciate what China has accomplished, we need to rewind to the late 1990s, a time when the country's transportation infrastructure was in crisis. Imagine a nation of well over 1 billion people trying to move across vast distances using railway technology that hadn't fundamentally changed since the mid-20th century. Trains were slow, overcrowded, and utterly inadequate for a rapidly developing economy. For Chinese policymakers, this wasn't just an inconvenience. It was an existential threat to the country's modernization ambitions. The government responded with a plan so ambitious that many international observers dismissed it as impossible. They would build the world's most extensive high-speed rail network from scratch, and they would do it in record time. The blueprint was called the 4 vertical and 4 horizontal rail layout, a systematic framework of high-speed corridors crisscrossing the entire nation. These weren't minor regional connections. These were massive trunk lines designed to link every major economic center, from the industrial heartlands of the north to the manufacturing powerhouses of the south, from the coastal megacities to the developing interior provinces. But China didn't stop there. As the first phase succeeded beyond expectations, planners expanded their vision to an even more audacious goal: the 8 vertical and 8 horizontal network, essentially doubling down on their original commitment. The numbers tell a story that seems, honestly, almost unbelievable. By the end of 2023, China's total railway network had grown to approximately 159,000 kilometers. Of that staggering total, more than 45,000 kilometers consisted of high-speed lines, tracks capable of supporting trains traveling at speeds exceeding 300 kilometers per hour. To put this in perspective, that's more high-speed rail mileage than the rest of the world combined. It's a network so vast that it has fundamentally transformed how Chinese citizens live, work, and connect with one another. Business people who once spent entire days traveling between cities now make the same journey during their lunch break. Families separated by hundreds of kilometers can visit each other on weekends. Economic opportunities that were once confined to coastal regions have spread inland as previously remote cities suddenly find themselves just hours away from major markets. And this infrastructure isn't just serving domestic needs. Through China's Belt and Road Initiative, this high-speed rail technology is being exported to Southeast Asia, the Middle East, Africa, and even parts of Europe. Chinese companies are building rail networks across multiple continents, fundamentally reshaping global connectivity and establishing new standards for transportation infrastructure worldwide. But here's the question that honestly few people ask. How did China build all of this so quickly? The answer lies not just in political will or financial investment, but in a manufacturing revolution that has transformed how trains themselves are made. At the heart of China's high-speed rail miracle stands a single corporate giant, the China Railway Rolling Stock Corporation, better known by its acronym CRRC. Walk through any major train station in China, and 7 out of every 10 high-speed trains you see were manufactured by this Beijing-based company. Established at the turn of the millennium in 2000, CRRC has gone from relative obscurity to becoming the undisputed heavyweight champion of the global rail manufacturing industry in less than a generation. The numbers are staggering. In the global rail transit equipment market, which includes everything from subway cars to freight locomotives to high-speed passenger trains, 4 major companies dominate. France's Alstom, Canada's Bombardier, Germany's Siemens, and China's CRRC together control approximately 82% of the worldwide market. But within that elite group, CRRC stands alone at the top, commanding a mind-bending 53% market share. That means more than half of all rail transit equipment being manufactured on planet Earth comes from this single Chinese company. How did they get so big, so fast? The answer is a combination of aggressive technological development, massive scale advantages, and, honestly, a relentless focus on manufacturing efficiency that would make even the most advanced automotive companies jealous. CRRC operates across a vast industrial network with research facilities, manufacturing plants, and service centers coordinated through sophisticated supply chains and production systems. The company has established partnerships and business relationships in 101 countries and regions, making it truly a global operation despite its Chinese roots. Consider just a few examples of CRRC's international footprint. In 2015, when Brazil was preparing to host the Olympic Games, it needed a reliable, modern subway system for Rio de Janeiro. CRRC delivered 90 subway vehicles that debuted on Metro Line 4, providing millions of residents and visitors with efficient transportation during one of the world's biggest sporting events. A year later, the Chicago Transit Authority made headlines by awarding CRRC a massive contract to manufacture 846 subway cars for America's third-largest city. This wasn't just a purchase order. CRRC established a local manufacturing facility in Chicago, creating jobs and transferring technology in the process. These aren't isolated cases. CRRC has delivered approximately 4,000 high-speed trains to customers worldwide, establishing what is unquestionably the planet's largest mass production system for high-speed rail vehicles. But here's what makes this story truly extraordinary. CRRC didn't just get bigger, they got faster, more efficient, and more technologically advanced than anyone thought possible. In October 2020, CRRC did something unusual for a Chinese industrial giant. They opened their doors to the world. The company invited journalists from the BBC and media representatives from 52 countries to visit their facilities and witness firsthand how modern high-speed trains are actually built. This wasn't a carefully staged public relations event with a few photo opportunities. This was an unprecedented, detailed look at the entire manufacturing process from raw components to finished train. What these international observers saw shocked them. Traditional train manufacturing, the kind practiced in Japan, Germany, France, and other established rail nations, is a labor-intensive, time-consuming process. Building a single high-speed train typically requires hundreds of workers laboring in massive workshops, carefully assembling components over weeks or even months. Even under optimal conditions with experienced crews, the fastest traditional manufacturers need nearly a month to complete a single train. But at CRRC's advanced facilities, reporters witnessed something entirely different. A modern high-speed train being assembled in just 12 hours by a team of only 30 workers. Let that sink in for a moment. 12 hours, 30 people, one complete high-speed train capable of safely carrying hundreds of passengers at speeds exceeding 300 kilometers per hour. How is this possible? The answer lies in a level of automation and precision manufacturing that represents the cutting edge of industrial technology. A modern high-speed electric multiple unit, the technical term for these trains, contains approximately 550,000 individual parts. These components range from massive structural elements and sophisticated propulsion systems to intricate electronic controls and passenger comfort features. Every single piece must fit together with extraordinary precision, because even tiny misalignments can cause problems at the extreme speeds these trains operate. In traditional manufacturing, skilled workers spend countless hours carefully positioning, fitting, and securing these components. It's meticulous work that requires expertise, patience, and tremendous attention to detail. CRRC took a radically different approach. They asked themselves how much of this process could be driven by data, controlled by computers, and executed by machines. The answer turned out to be almost all of it. Inside CRRC's most advanced production facilities, the assembly line is orchestrated by sophisticated computer systems that control every aspect of the manufacturing process. Industrial robots, massive mechanical arms with precision capabilities measured in fractions of a millimeter, perform the majority of the heavy lifting, positioning, welding, and assembly work. These aren't the simple, repetitive robots you might see in an automotive factory doing the same single task over and over. These are intelligent, adaptive systems that can handle different components, adjust to variations in materials, and coordinate with other machines to complete complex assembly sequences. Each robotic unit follows meticulously programmed instructions, working with a speed and consistency that human workers simply cannot match. They don't get tired, they don't make mistakes from loss of concentration, and they can operate continuously around the clock. But here's what's crucial to understand. This isn't about replacing human workers entirely. The 30 people involved in this 12-hour manufacturing process aren't standing idle while robots do all the work. They're operating in a completely different role as system supervisors, quality controllers, and problem solvers who monitor the entire process through networked computer systems. When something unexpected occurs, a component doesn't fit precisely as expected, or a sensor detects a potential quality issue, these human operators can intervene, make adjustments, and ensure the final product meets the exacting standards required for high-speed rail operation. This human-machine collaboration represents a new paradigm in manufacturing, one where automation handles the routine, physically demanding, and precision-critical tasks, while human intelligence focuses on oversight, quality assurance, and continuous improvement. The efficiency gains are remarkable. Where traditional train manufacturing might require hundreds of workers spending weeks on a single vehicle, CRRC's system produces a completed train in half a day with a skeleton crew. This isn't just faster, it's fundamentally more efficient, more consistent, and more scalable. When demand increases, CRRC doesn't need to hire and train hundreds of additional workers. They simply run their automated lines longer or bring additional production facilities online. For decades, Japan's Shinkansen, the iconic bullet train, represented the gold standard in high-speed rail. When Japan launched the world's first high-speed rail service between Tokyo and Osaka in 1964, it wasn't just a transportation breakthrough. It was a national symbol of post-war technological renaissance and industrial prowess. Japanese engineers pioneered many of the core technologies that make high-speed rail possible. Their trains became synonymous with reliability, safety, and precision, qualities that matched Japan's broader reputation for manufacturing excellence. So when news began circulating about China's claim to build complete high-speed trains in just 12 hours, Japanese industry observers were skeptical, to put it mildly. The numbers simply didn't seem plausible. In Japan's most efficient factories, building a Shinkansen train set required extensive time, substantial labor forces, and careful craftsmanship. The idea that China, which had essentially learned high-speed rail technology from Japan and Europe, could now outpace their teachers so dramatically seemed far-fetched. Japanese media organizations decided to investigate. They sent reporters to CRRC facilities in China with a mission: verify whether these extraordinary claims about 12-hour train manufacturing were real or merely propaganda. What happened next was documented in detail by Japanese journalists who expected to expose exaggeration, but instead found themselves confronting an uncomfortable truth. The reporters toured CRRC's advanced manufacturing facilities, observed the automated production lines in operation, and timed the actual assembly processes. They interviewed workers and managers. They examined the finished trains and reviewed quality control data. Their conclusion? Not only were the claims true, the reality was in some ways even more impressive than advertised. The Japanese journalists witnessed firsthand the sophisticated integration of robotics, computer control systems, and precision manufacturing that made 12-hour train production possible. They saw the minimal human workforce required. They observed the quality and sophistication of the finished products. For an industry that had long viewed Japan as the unquestioned leader, this was a sobering moment. The reports that came back weren't dismissive or critical. They were filled with genuine admiration mixed with concern about Japan's competitive position. One Japanese railway industry analyst was quoted saying something remarkable: that in terms of manufacturing speed and efficiency, China had not just caught up to, but had fundamentally surpassed what Japanese companies could achieve with current technology and methods. This wasn't just about bragging rights. Speed of manufacturing has profound implications for the entire economics of high-speed rail development. When you can produce trains faster, you can deploy new capacity more quickly, respond to demand surges more effectively, and ultimately deliver transportation infrastructure at lower cost. For countries considering investing in high-speed rail networks, whether in Southeast Asia, Africa, the Middle East, or Latin America, China's manufacturing capabilities make their proposals significantly more attractive than competitors who need months to produce what CRRC can deliver in days. The European manufacturers, Siemens and Alstom, face similar challenges. While they maintain advantages in certain specialty markets and technological niches, they cannot match CRRC's combination of scale, speed, and cost-effectiveness in mass production. This has created a fascinating dynamic in the global rail industry. The established players who pioneered high-speed rail technology now find themselves competing against a manufacturer who learned from them, then innovated beyond them in manufacturing efficiency. China's high-speed rail success story is about more than just trains or manufacturing efficiency. It represents a broader transformation that has caught much of the Western world off guard. For years, many people outside China, particularly in Western countries, held a perception of China as technologically backward, a developing nation still catching up to advanced industrial economies. This image was reinforced by media coverage that often focused on China's challenges rather than its achievements, frequently comparing it unfavorably to more developed Asian nations or Western countries. But anyone who has actually visited modern China in recent years encounters a jarring disconnect between this outdated perception and present-day reality. Walk through cities like Shanghai, Beijing, Shenzhen, or Guangzhou, and you'll find infrastructure that rivals or exceeds anything in New York, London, or Tokyo. Gleaming skyscrapers define skylines. Public spaces are clean, well-maintained, and integrated with advanced technology. Mobile payment systems are ubiquitous to a degree that makes most Western cities seem antiquated. Surveillance and traffic management systems employ artificial intelligence at a scale unmatched anywhere else. And everywhere, connecting these modern cities, are those high-speed trains, arriving and departing with clockwork precision, carrying millions of passengers daily through a network that spans the entire nation. This cognitive dissonance between the dated perception and contemporary reality reflects a larger challenge for observers trying to understand China's role in the world today. The high-speed rail network and the manufacturing capabilities behind it aren't isolated achievements. They're part of a systematic approach to industrial and technological development that China has pursued relentlessly over the past several decades. The same manufacturing philosophy that allows CRRC to build trains in 12 hours is being applied across numerous sectors, from renewable energy equipment to telecommunications infrastructure, from electric vehicles to advanced electronics. The pattern repeats. Learn from established industries, invest massively in research and production capacity, achieve economies of scale, then innovate in manufacturing efficiency. For the 1.4 billion people living in China, the impact has been transformative. Cities that were economically isolated a generation ago are now seamlessly connected. Opportunities that were once concentrated in a handful of coastal regions have spread inland. The ability to travel quickly and affordably has expanded possibilities for education, employment, and personal connections in ways that are hard to quantify but impossible to overstate. Consider what this means for someone living in a mid-sized Chinese city in the interior of the country. 25 years ago, traveling to a major coastal city for business or education might have meant an arduous journey of many hours or even days on slow trains or buses. Today, the same trip might take just 2 or 3 hours on a comfortable high-speed train, making it feasible as a day trip or easy weekend journey. This transformation in connectivity has economic multiplier effects that economists are still trying to fully understand. When travel time between cities decreases dramatically, it effectively makes the entire region function more like a single integrated economic zone. Labor markets become more efficient. Businesses can operate across broader geographic areas. Knowledge and innovation spread more quickly. And increasingly, this isn't just a domestic story. China's Belt and Road Initiative is exporting this model globally, with Chinese companies building high-speed rail networks and related infrastructure in countries across Asia, Africa, and beyond. So what does it all mean? This story of trains built in 12 hours, of manufacturing revolutions, of a country transforming from railway backwardness to global dominance in just 25 years. At one level, it's a remarkable tale of technological achievement and industrial capability. The ability to assemble a sophisticated, safety-critical machine like a high-speed train in half a day with minimal human labor represents a genuine breakthrough in manufacturing efficiency. But at a deeper level, it's a story about how quickly the world can change when commitment, resources, and systematic thinking align toward a clear goal. A quarter century isn't very long in historical terms. In 1998, when China's high-speed rail ambitions were first taking shape, many of the journalists reporting on CRRC's facilities in 2020 hadn't yet been born. The internet was just becoming mainstream. Smartphones didn't exist. The world looked profoundly different. Yet in that relatively brief span, China went from having essentially no high-speed rail to operating a network larger than all other countries combined, served by trains manufactured at speeds and efficiencies that traditional rail powers cannot match. This raises uncomfortable questions for other nations. If China could accomplish this in transportation infrastructure, what else might be possible in other sectors? What other industries might see similar transformations? And what does it mean for global economic competition when manufacturing efficiency reaches this level? There are no easy answers. What's clear is that the old assumptions about who leads in technology, about how long industrial transformation takes, about the immutability of competitive advantages, need to be reevaluated. The next time you see a high-speed train gliding silently through a station, consider this. That machine, with its 500,000 precisely engineered parts, its sophisticated propulsion and control systems, its ability to transport hundreds of people at breathtaking speeds in complete safety. That machine might have been assembled in less time than it takes to fly from New York to London. The factory that built it is already working on the next one. And the revolution in manufacturing efficiency that made it possible is still accelerating. The question isn't whether China has changed the game in high-speed rail manufacturing. That much is undeniable. The real question is, what comes next? Thank you for watching. If you found this exploration of modern manufacturing and transportation infrastructure enlightening, please subscribe to stay informed on the technologies, industries, and innovations reshaping our world. Leave your thoughts in the comments. We'd love to hear your perspective on what China's high-speed rail revolution means for global transportation and manufacturing. Until next time.